Good morning, fifth grade mathematicians. It's Mrs. SJ here. Happy Friday, September 18th. We are back here in our math live lesson. We are reviewing how to compare fractions. And really, the key piece is we are no longer comparing fractions with like denominators. We are considering all types of fractions and really spending time to think deeply about what does a fraction mean when we see a specific number on the top numerator versus the bottom down denominator. And so really, before we get started, I want you to double check that you have your math notebook and a writing utensil for our lesson. And really, we're going to be reviewing what we talked about in yesterday's lesson. I have our number line still up on the board that we are going to go over. And we're also going to talk about a few other strategies other than the number line for comparing fractions. So, before we begin, you are giving me a thumbs up that you have your materials. Otherwise, pause the video and go ahead and grab them. I can see that there are 5 of you here. Hopefully, we'll get a few more mathematicians joining us. In the meantime, you are either repeating these teaching points out loud with me or writing them down. If repeating them out loud is better for you to remember, then just go ahead and read it out loud with me. Our teaching points for the day are: I can identify equivalent fractions. Say it with me. I can identify equivalent fractions. Our second teaching point is: I can use a number line or other visual representations to compare fractions. Say it with me one more time. I can use a number line or another visual representation to compare fractions. So, give me a thumbs up if you're ready to begin. Excellent. Wonderful. I see there are a few more of us here. I believe that if you have a Google account, you are able to chat in the live chat. And if you don't have a Google account, you are not allowed to chat in the chat. So this might be a great conversation to have with your families so that you can be able to really interject in this live lesson so that you can have your question answered immediately. That is why we are enabling the live chat, is so that there is a interactive component to this live lesson, right? This is the key piece. So let's start with reminding ourselves that there are 3 strategies for comparing fractions. Say it with me. There are 3 strategies for comparing fractions. The first strategy is making a number line. The second strategy is drawing a circle representation of the fraction. The third strategy for comparing fractions is drawing a fraction strip, right? And when I call a fraction strip, what I really mean is drawing a, and we'll go over it. Fraction strip, a rectangle, if you will. So now that we have these 3 strategies, I want you to take a moment and consider. Have you seen all 3 of these before? Take a minute to think. Where have you seen these representations of fractions before? And have you seen every one of them? So if you have come into contact with a number line, which all of you have if you watched yesterday's math live lesson, right? So I should see 1 thumbs up. If you have drawn lots of circles, which I have done a lot of representing fractions with circles, and give me a 3rd finger up if you have drawn lots of fraction strips before. Absolutely. Oh, excellent. Welcome, Quincy. I see that you are here, and there are 11 of us. Amazing. Talk about a fraction. Goodness, let's compare. We have a class of 30 students, right? And That is our denominator. Right now there are 11 of us. Is that more or less than half? 1/2 of a fraction, right? And the way that we would compare 11/30 with 1/2, let's see, do we even have half a class right now? Okay, how would we draw and compare this? Well, I would need to draw, if I was going to do a number line, right, I would need to draw a number line. Okay, here's my number line. I have 0 and I have 30, right? What is half of 30, right? Well, I'm going to draw my 0 and my 1 because this is the 1/2, right? Well, for this number line, it would be 15, would be the halfway point. And 11 is over here. Which one's more? 11/30 or 1/2? That's right. 1/2 is greater than 11/30, right? Now, if I was going to draw a circle representation of 1/2 compared with 11/30, I would first draw a circle, right? And let's see here. Here we go. I'm going to draw it on this side. If I'm going to draw a circle, I'm going to draw 2 circles because I'm comparing these fractions. Well, I know that based off of that denominator, I'm only cutting this into 2 pieces. But for this one, I'm cutting it into 30 pieces, right? So that would take quite a long time, but I know that I can draw it pretty quickly if I go. I know that 15 is going to be on each side. So if I cut it into thirds, I know that each one is going to be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, this is where things get interesting because I know I have one of these 2 pieces, right? This is why 1/2 looks like that. Now, I'm going to color in 11 parts, okay? So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Woo! Which one is more? Well, 1/2 has more space filled, right, than 11/30. So here's another way I am representing that I am comparing these 2 fractions. So I know that we have less than a whole class right now if there are 11 out of 30. And wow, now we have 13 out of 30, right? So this still, consider if we had 2 more people show up in this time, do we still have half a class? No, not quite. It still is less than 1/2. Now, if I was going to draw a fraction strip, okay, so here we have 2 number lines, 2 circles, right? If we're comparing 2 fractions, we need 2 different ways of representing these numbers, right? So a fraction strip reminds me a lot of circles, but obviously it's a strip. It's a fraction strip. So we need not 1, but 2 strips. Okay. Now, the first one, once again, if I'm looking at 1/2 compared with 11/30, well, I'm looking at the bottom to let me know how many times I'm chopping it up, right? You all know at this point that the bigger the denominator, the smaller the piece, right? Because the 30 represents how many times It has been divvied up. So if I'm looking at 1/2, I know I am making this into 2 equal pieces. Here's 1/2 plus 1/2 equals 1 whole, right? I know that. 1/2 plus 1/2 equals 2 halves, which also equals 1 whole. If I was going to add up 30 pieces, I should get 30 over 30, right? Which would equal 1 whole. Now, let's see. We know that half of 30 is 15. And so that means I want to draw 5 equal strip. 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we're going to split it up into thirds again. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. If you notice, I split it up 5, 10, 15, 20, 25, 30. So now we have to fill it in, okay? Excellent. So I'm going to take another color to represent me filling it in. Well, if I have 1/2, that means I have one of these 2 halves. This is where having colored pencils can come in handy with fractions. I love using colored pencils during fractions and having a pen to use as well. Now for this 11 over 30, this can be tricky, right? But I know that I am adding up 11 1/30ths, right? Each one of these squares represents 1/30th, right? So essentially one of these squares is you, right? And I see a handful of my squares using our live chat for just to say hello to one another. But remember that we are using it to ask questions, okay, and to confirm what I'm talking about. So, you know, if I was adding up classmates, I know that Quincy's here, that's 1/30th. I see Marco's here, that's another 30th, so that means that we have 2/30ths. Then we have Adrian, that's 3/30ths, right? But we need to count all the way up to 11, right? So we have 1, 2, 3, 4, 5, 6. Count with me. 7, 8, 9, 10, and 11. Now, the thing I love about fractions is that when you use a visual representation like circles or fraction strips, you can visually see that 1/2 is actually takes up more space than 11/30ths. Okay? And really, this is like the key piece of saying, well, I know that 1/2 is greater than 11/30ths. Okay? So this is really key. Now, I love it. I'm looking around and seeing that there are a lot of people here. Our first fraction that we were talking about really was a real life thing that I wanted to see. Do we have half of our class here when we started? Well, when I first started, there were 11 live viewers, which means that there were 11 students watching out of 30. And I wanted to know, do I have 1/2 of my class here? Is 1/2 greater or less than 11/30ths? Well, we were able to answer this after finding 3 different ways to show that 1/2 is greater than 11/30ths, which means that at the start of this, we had less than half of our class here, right? Now I'm looking and I'm seeing there are 17 of us here. And I know that that magic halfway point was which number? If you know, you can write in the chat. What's our magical halfway number for 30, right? What would be the equivalent fraction of 1/2? What is our equivalent fraction of 1/2? How would I know if we had reached our magic number of having half of our class? Let's see if someone can answer in the chat. I'm going to give some think time. What is our classroom equivalent number to equal 1/2? I'm seeing one answer response in the live chat. I love it. Let's see if we have any agreements or disagreements. You can show me, do you agree or disagree with, I believe that was Dermot. Excellent. So we would need 15 out of 30 to equal 1/2. And that is quite light. So I'm going to rewrite that so that you can see it nice and bright. So the class's equivalent fraction, so that we know we have 1/2 of our class, is 15 out of 30. Consider, if we have 15 students plus another 15 students, that equals 30 kids, right? That means that we would have one class. Similarly, 15 divided by 2 and 30 divided by 2, right? If we divided this by 2/2, that simplifies down to 1/2, right? Oh wait, silly me. I made a mistake. It doesn't equal, if I divide 15 by 2, that's not going to equal 1/2. What would I need to divide it by? What would I need to divide 15 30ths by to get to 1/2? Let's think. Absolutely. We would need to divide it by 15. If I divide 15 by 15, what does that equal? 15 divided by itself equals 1. And 30 divided by 15, well, I know that 15 times 2 equals 30, right? So our equivalent fraction for 1/2 is 15 30ths. So the numbers that you are going to be getting for your exit ticket are much smaller than 1/2 compared to 11 30ths. So I think that we should try one more together, and then the rest you'll do on your own for guided practice and the exit ticket. Okay, so take a quick peek. I'm going to move out of the way so that this is a great place to pause if you need to catch up on these notes. Do not panic. When I erase this board, it's not like it's gone forever. You can always go back and pause so that you are going at your just right pace for taking notes. Okay? So now I'm going to erase. Say goodbye. Okay. Our next fraction that we are going to do together, our next two fractions that we are going to compare together are the first fraction from our comparing fractions part 2. So we are going to take this fraction, which is 6/10 compared with 3/4. 6/10 compared with 3/4. Well, if I want to first look on a number line, okay, and it really is going to help you if you have your own number line poster that you can look at. For now, we're going to actually use my fancy number line poster to take a look, okay? And I really want you to think about, how can I tell on a number line? if 6/10 is greater or less than 3/4. Okay, so I am actually, ooh, this is perfect. So this will be nice and close. You should be able to see this. So if I'm looking at 6/10, I want to locate where 6/10 are. And really, when I look at this, I know that 6/10 is also, I can simplify it, right? If I simplify 6/10 and divide it by 2, that's going to give me 3/5, right? And we figured that out when we did a lot of, when we made up our own number line in yesterday's video, okay? And so that's a great one to take a look at. Again, if you're feeling a bit confused. So take a look. Here is where 3/5 is. 3/5 is also equivalent to, that's right, 6/10. Now I also want to locate 3/4, right? And 3/4 is all the way over here. And if I look at this, I know this is greater than 1/2. I should know that both of these are greater than 1/2. If I know what half of 10 is, which is 5, and this is, the numerator is more than 5, I know this is greater than 1/2. Similarly, I know that if the numerator here is greater than half of 4, right? So if it is greater than 2, that means it's also greater than 1/2. But that doesn't help me. If I know now that both of these are greater than 1/2, I need to figure out exactly how much more greater than 1/2 they are. So take a look. Here's our halfway point. Here is 3/5, and here is 3/4. So if we're looking at a number line to compare these two, that means that we can see that 3/4 is only 1/4 away from 1 whole, and 6/10 is 4/10 away from 1 whole, right? If I was going to use a circle to compare these two, pardon my bonks. A few things are falling down. No worries, we're all safe here. Okay, so once again, we're comparing 6/10 and 3/4. Well, if I'm going to draw a circle, first I'm going to draw one circle that represents 6/10, and then the other circle I need to draw representing 3/4. Now the first thing I'm going to do is, I love always starting off drawing a circle by figuring out the half point, okay? And I know if I need to split this up into 10 pieces, each side needs 5. And as a good mathematician, I'm always going to double check and double count my work, okay? So there's 1, 2, 3, 4, 5. Those aren't super equal, so I might try again to make it a little bit more equivalent. That they're split up into equal parts. So let's try this again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now I'm going to set this one up. And this is split up into how many pieces? Into 4 pieces. Okay. Now I'm going to get a different color, and I want to color in and see how much of the pie is taken up. Well, let's count. 1, 2, 3, 4, keep it up, 5, and 6. Okay. Now, this next one I'm going to count, I'm going to fill in how many pieces? 3 pieces. 1, 2, 3. Can we look and see which one has more? Yeah, absolutely. 3/4 is greater than 6/10. And last but not least, and thank you for bearing with me in this lesson. It is a longer lesson. And I want to remind you that when you're doing the exit ticket, you are choosing only one of these strategies. You are not doing all three. You are choosing the one that works best for you. If you would like to try doing all three of these strategies, one problem do the circle, one problem do a fraction strip, and another problem do a number line, great. You are making a choice that's just right for you. Last but not least, we're going to do our fraction strips. And I'm going to do my very best to make sure that the fraction strips are the same length, okay? I really want them to be the same. And if I'm also going to be nitpicky, I want to make sure that they look pretty similar. Okay. I know that this top one needs to be split up into 10 pieces, right? So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This bottom one is split up into 4. Okay, and I'm going to color in 6 out of the 10, right? Because this is 6 out of 10, and this is 3/4. So 1, 2, 3, 4, 5, and 6. All right, let's do our 3/4. 1, 2, and 3. Which one has more? That's right. We know 100% that 3/4 is greater than 6/10. So, kiddos, today we learned a lot. We learned 3 ways to represent fractions. Not just how to represent fractions, but how to compare fractions with a number line, a circle, or a fraction strip. Now, we just solved the first exit ticket equation. The rest you're doing on your own. And remember, you are only choosing one method, one strategy. You are not doing all 3 strategies for one equation. No. That's too much. You are choosing which one is a strategy that you like the best. Okay? All right, kiddos. Have a good one. I will see you soon.